Saxon's Trig, lesson 47, is about vertical sinusoid translations and arctangent, starting on page 328. So we just learned the other lesson about sinusoids, which is when we are graphing the curves that happen when we unroll a circle that was created by rotating a right triangle. And the applications are things like sine wave, and I did it again, not sine waves, sound waves, or radio waves, that kind of thing. Those are the application points. But what we're learning here is what happens when on our grid, instead of starting at 0, we shift it a certain amount of, I want to make sure I was doing the right one. They're changing the height. Where the height begins. There's what I'm looking for. So this is normally represented as 0, 0. If, however, I changed it to be 60 and I said my height is 2, then my high point would be 62, my low point would be 58, and then depending on whether I had a sine or cosine, whether I would start high point, middle, or low point, and whether they were positive or negative, I would still automatically have the 4 sections ending in 360 degrees. So if we change where our center line is, it's no longer at 0, it's shifting up or down, where do we see that in an equation? And so if I started this one in the center, I'm trying to follow their example here, and it went up first to the high point, low point, and return. Here, okay, so here is the picture that they gave you, and they said the graph of this looks like, and we know that starting in the center, we've used the word sine, and at the end there is a theta, so we know it's going to be sine of theta. And our height was 2, and we put that number directly in front of the word sine. But when the center line has changed, that goes in front. So this now says 60 plus the 2, or if this had gone down first, this would have been minus 2. But if you have a number separated all by itself in front of the rest of it, you know that you're changing the center line. So in example 1, it says write the equations for the 2 sinusoids shown. All right, so for the first one, now I will caution you, when you are looking at what number they have given you here and they write it kind of over top of the X line, it can get lost if it's a negative into the line. Sometimes they're super clear and sometimes it's not as clear. So I always double check based on what they give me for the high and the low point to make sure that I've not lost a negative. See, when I look at their dashed line that created this x-axis, it makes it look like it's a -4. But what they provided was a 6 for the high point and a 2 for the low point. Once I look at that, I realize, no, that's 2 above +4, that's 2 below +4. Nope, that's definitely a +4. And then their 4 sections ended at 360. The end sine. Oh, this one they didn't write at the end. This one they wrote it on an arrow above, and they said that it's positive theta. Now they don't really need the positive part, but they're going to clarify it just for precision's sake. So when you see the positive theta, it just means you're putting theta in your equation. Now your graph started at 0, 0. It went up. Okay, so now ultimately what it was looking for was the equation here. So y equals, did we change where the center line is? Yes, it began at 4. It went up first, so I know it's a positive. Did I have a change in the height? It's not just 1. Yes, that was 2. And because it started in the center, I know I'm going to use the word sine, and I pull my theta from the end. So 4 plus 2 sine theta. Okay. There's a second one in this same example 1, and it gives us -6 for the height, -10, again, it was hard to catch that, I had to look carefully, and -14. But I double check from -10 up to -6, that's a gap of 4. 4 below that, -14. Yep, good to go. Okay, so this one started at the center still. It went down. My 4 sections, it ended at 360, so no change there. My arrow indicated, again, a positive theta, and it went down and returned. Okay, there was the graph that they gave you. So we know we're going to have y equals, what is our center line? -10. What is it goes down first, so I know this is going to be minus, and then my height, we already said, was a gap of 4. And started in the center, word of sign, and then the theta from the end. Okay. So it should be pretty simple to be looking at these and pulling the parts now that you know what you're looking for. Example 2 gives you 2 more. Again, this is -8. I double checked carefully with my -5 and -11. So from 8 to 5 is 3. 8 down, 3 more. Yep, that's 11. So my height is going to be 3. This one started at the peak. 1, 2, 3, 4 sections. High peak was, again, got to here at 360 degrees. So we're good to go. All right. So that's what they gave you. We are going to have y equals, again, the center line is -8. It started above, which is going to keep it positive. The height we've already found at 3, and because it started above, we know it's the word cosine, and the arrow gave me a positive theta, so cosine of theta. Okay, last one of those. Again, it was hard to tell, but it's definitely a 7 and a 9. So I'm assuming my height is 2. 2 below that would be 5. That is what they gave us. It started down here. 1, 2, 3. Oh, that was a little too far. Sorry, I try to keep them spaced evenly. And then from the low point to the matching low point, that is at 360 degrees. So the curve they gave you is here. The arrow gives you positive theta. Okay. Whoops. So y equals center line of 7, started below, so it's minus. The height was 2. Because it started below, the word is cosine and theta. Yep. Now, part B is arctangent. Now, remember that the word arc is asking you for the degree. Now, this one is just a little bit weird, and I differ from what they say, and I'll explain what's happening. Tangent of 135 degrees. All right, so my first instinct is to graph the 135 degrees, which would land over here, and that would be a gap of 45 to get to the 180. So here is the degree, and I would, if I were labeling it 1, 1, radical 2, so then the tangent of that would be TOA, opposite over adjacent, 1 over 1, so that would be 1. And then it's asking for what is the degree for 1 with the word tangent. Well, tangent is still opposite over adjacent, and if I graph 1, I would graph it in a different location. Okay, so this is where they differ in their answer from what I want to do. When they graph this opposite over adjacent, they put it in this quadrant, not quadrant 1. And I don't instinctively want to do that because this is a positive. I want to put it in quadrant 1. All right, so to avoid that, I have learned to look at if they want the degree, oh, well, let me just finish that thought then. 1, 1, radical 2, is that not still 45 degrees? Yes, okay, so arctangent wanting the degree, given the same word tangent, ends up giving the same degree that you get in that triangle. So I would say that when you see tangent and arctangent sitting side by side, they're killing each other off, leaving you 135 degrees. And I would accept 135 degrees as the answer. But in math, we typically want it in the smallest form, and that's why we end up giving it the 45. Now, the book carries it one step further and says it should be negative 45. Again, I can argue the fact that when I graphed 135, I was in this quadrant. This is clearly the key degree, But when I go to graph the arctangent of 1, I can see their argument of being in one of these two quadrants. So take that as you will with all of that.